so much. It's better to use that.
Okay. Thank you for your introduction. And I'm introducing the last presentation of the Promisces project. I'm Massimiliano Sgroi from Università Politecnica delle Marche in Ancona, and I will talk about the case study of 5 of Promisces project, that is the treatment of dredged sediment in the port of Ancona. We have in Ancona concurrent projects. Ecosera, it was funded by Regione Marche. He funded the realization of a prototype at demo scale to treat by soil washing contaminated port sediment to remove hydrocarbons and heavy metal, typical contaminant that you can find in dredged sediment. And the goal is to remove these pollutants, to recover sediment can be used for road construction. So we connected this project with Promisces. Promisces is investigating the fate of PFAS compounds. So we used the Ecosera project to investigate the fate of PFAS during soil washing treatment. Well, so the step we did. Before we did some tests at laboratory scale, simulating the real Ecosera pilot treatment. Based on the treatment that we did on laboratory scale, we designed and we realized the prototype at pilot scale. So we did different tests with different washing cycle. We had acidic washing cycle, basic washing cycle, and then final washing with just top water, more or less neutral pH. These are some of the tests we performed at laboratory scale. In addition, we had the chance to receive another matrix of sediment from Netherlands that was much more contaminated than the sediment from Ancona. So we tested 2 different matrices. This is the prototype that we realized at demo scale using the funding from my Ecosera project. You can see the schematic. There is different step, crushing, and then selection between dry grade and fine sediment, then the washing, the recycle, then the watering, filter press, and then use the use of this material for road construction. Of course, during this treatment, we produce different fractions: solid fraction, the saturated, cleaned, and liquid fraction that probably, of course, will contain the removed contaminants. So we added additional treatment to remove the PFAS. So these are the step after the pilot Ecosera treatment. In the first treatment on the right is an alternative treatment. Is a thermal treatment. We have a pyrolysis reactor, so it's an alternative treatment to vessel washing. Wash the sediment, the solid part, we immobilize it because we have to create material for plant construction. So we did the leaching test to evaluate if some PFAS remained in the solid, if there is the possibility that we can have leaching from this material. And then, of course, we have the washing water. You saw the previous presentation, it was an cavitation. We will work with Panda. We will send to them our liquid fraction. They will treat the liquid fraction to evaluate the possibility to reduce, to remove the PFAS in this liquid fraction. These are some of the experiments that we did at laboratory scale using sediment from Ancona. You can see the concentration in the first column, in the second column of the detected PFAS in the raw sediment. Then still some sediment, some PFAS was detected, mostly PFBA. Probably there is a precursor transformation, and PFBA was the most detected PFAS in our samples. Then what we found in the solution, in the acid washing, in the alkaline washing, and the final washing. The biggest concentration was found in the acidic washing, when you use acid and we wash the sediment at low pH. This is also fluorescent spectra. It's a technique that allows us to study evaluate the content of the organic matter in the liquid. So they are the washing solution. Of course, PFAS will be complexed with other organic material. So doing the washing was the step where we removed most of the organic material. In this trial, it was the acid washing the step where we observed the highest removal of PFAS. We also then we tested at pilot scale. So we did the similar test at pilot scale, where the efficiency was not so good as the pilot scale, probably because the mixing was different. We had a pump with a recirculation, so it was not so effective like the lab scale. But in any case, we have removal. You can see also from the fluorescent spectra the organic material that was removed was lower. Also, we had another matrix from Netherlands. The contamination was much higher. And you can see the concentration of the sediment, the treated sediment. There was a removal of some of the PFAS, and most of them in the liquid diffraction were detected during the alkaline washing. If you can see the fluorescent spectra, even in this case, the biggest removal of organic material was observed in alkaline washing, during the alkaline washing. Of course, we had different sediment, different matrix, different organic matter that had a different answer to the washing cycle that we applied. Here you can see the synthetic representation of organisms, where we are comparing the concentration of the raw treated sediment with the proposal threshold by the proposal of UNIVPM directive. All the concentration were transformed in PFA equivalent and were compared with the red line that represents the possible threshold that we will have in the Camino directive. From Ancona sediment, when we treated at a laboratory scale, we were able to respect this threshold. When we used the much more contaminated sediment from Netherlands, we were not able to reach this, to respect that limit. Of course, was another organic material, the contamination was much higher. We were able to remove PFAS, toxicity of the PFAS, but we were not able to reach to go below the limit of the proposal directive. Then we realized that also some model to test the mechanical characteristic of the material to be used for the road construction. We performed the leaching test according to the method of EPA, that is the ones employed to test the leaching of organic contaminants. It's not the conventional one that by normal we use for analyzing the leaching of heavy metal or mechanical. It is more specific for organic compounds. We tested using elution at different pH. So we have the basic solution of acid to reach different pH. You can see the titration curve. And here are some of the results. So we selected three examples that were a basic, neutral or acid condition. What we can see it's more a contamination issue related to acid addition, because during the stabilization we used the lime. Because when we did the leaching test just with the raw sediment, we didn't observe leaching. But when we add concrete, we add the lime, we analyze acid, probably the product that we use to create the model, that they contain PFAS. So the leaching was more problematic from a contamination side. Then these are the next step that we are going to do. We will use of speech is the same pyrethroid reactor that we used for treating the concentrate of laminated leachate, and we will simulate a thermal treatment. Even for the more contaminated sediment that we were not able to treat in a satisfactory way to reach a concentration of PFAS below the standard, the threshold that is suggested by the new directive. So just the conclusion, Ecosedra, yeah, when was operated the laboratory scale for the Ancona sediment, the low medium removal was effective to have a good performance on the removal of PFAS. For more contaminated sediment, we had more problems. When operated at pilot scale, improvement are needed in the pilot, probably, especially during the mixing. The mixing has to be, the mixing phase has to be improved. And regarding the leaching test, we didn't see leaching test from the treated sediment from Ancona port, because we tested the leaching test only from Ancona sediment that were produced in much higher amount from the pilot and were used to produce a model for testing for the road construction application. From that sediment, we are testing sediment with low contamination. We didn't observe leaching from these sediments. And thank you for your attention. And thank you so much. If you have some questions, I am here for answering.